Hello and welcome to Cambridge Advanced Level Mathematics here, where we practice and solve past examination questions. But in today's lessons, we just want to discuss two simple but important theorems in algebra. They are the remainder theorem and the factor theorem. Let's illustrate this with an example. Supposing I have to divide x minus 2. Let me write it here. I need to put some space for the quotient there. So x minus 2 dividing x cubed minus 7x squared plus 6x minus 2. Okay, so we need to divide this f of x by that. We proceed exactly as in our long division back in primary days. So we look at this and that. How many times does x go into x cubed? It goes x squared times. Then we multiply. X times x squared is x cubed. X squared times minus 2 gives you minus 2x squared. Then we subtract x cubed minus x cubed, 0. Minus 7x squared minus 2x squared gives us minus 5x squared. Then we bring down these two guys, that minus that. Again, we look at our 5x squared. How many times does x go into minus 5x squared? It goes minus 5x times. So it's minus 5x. Then we multiply. X times minus 5x is minus 5x squared. Minus 5x times minus 2 is plus 10x. Then we subtract. 5x, sorry, this is minus 5x, minus 5x minus 5x, which is nothing. Then 6x minus 10 is minus 4x. Then we bring down our 2. Again, we look at this. X into minus 4x is minus 4. It goes minus 4 times. Then we multiply out. X times minus 4 is minus 4x. Minus 4 times minus 2 is plus 8. We subtract this and that, nothing. Minus 2 minus 8 is minus 10. This is the remainder. So we can, this means that this function f of x is equal to this multiplied by that remainder minus 10. So we can write this as f of x is equal to x minus 2 multiplied by x squared minus 5x minus 4 remainder 10 minus 10. So in general, of course, we can write f of x is equal to x minus a multiplied by some quotient q of x plus some remainder. Okay, so f of x, when we divide it by x minus a, it's going to give us a quotient plus a remainder r. What if we put x is equal to r? Then we have f of a is equal to a minus a, which is 0, multiplying q of x, q of a, of course, plus r. This, of course, is 0. So f of a is equal to r. What does this mean? This means that when f of x is divided by x minus a, the remainder is given by f of a. So let's write that. This is our remainder theorem. Maybe I should write it, I can put it on top here. Let's put it on top here. the remainder theorem. Remainder theorem. Okay, so it says that when f of x is divided, divided by x minus a, comma, the remainder is f of a. Okay, so let's just make sure this stands out clearly. So that is the remainder theorem. That is the remainder theorem. So when we divide f of x by x minus a, the remainder is f of a. The remainder is the value of f of x when you substitute x a for x. Now, if we then find, what if we find that when we put f of a, we find 0. So if f of a is equal to 0, remember we have here, let me write it in blue just to make it different. Remember here we have f of x is equal to x minus a multiplying some q of x plus r, right? Now, if we put f of a and we find that it is equal to 0, that means that this obviously vanishes because that will be a minus a, which is 0. So that will be f of a is equal to 0, meaning r is equal to 0. If f of x is equal to 0, so let's do that here, implying that r is equal to 0, comma, what can we conclude? Then then x minus a is a factor of f of x. This then is the factor theorem. So this we can write as factor theorem. This is the factor theorem. So when f of x is divided by x minus a, the remainder is f of a, which is the remainder theorem. But when we discover that f of a is actually equal to 0, that means the remainder is 0, which also implies that x minus a is a factor of f of x. So that is the factor theorem. A good example of the use of the factor theorem is for supposing we are given f of x is equal to x cubed minus 3x minus 1, right? And we want to know if x minus 1 is a factor, or x minus 1. What do? Let's put f of 1. We have f of 1 is equal to 1 minus 3 minus 1, which is not equal to 0. Therefore, x minus 1 is not a factor. Okay, let's take a simple and straightforward example just to illustrate the use of the remainder theorem. Supposing f of